Hi and welcome back to R for BRFSS. I'm Jennifer, your instructor for this tutorial series. We are now on the third and final chapter of our segment on prevalence estimates. We just set our survey design using BRFSS weighting variables, analyzed our data, and then formatted our data into a table. Now we're going to work on some data visualizations. So I'm recording all of these videos on the same day. I haven't closed out my R session, so I have all of my information already in the R console. But in the past, I've just left R open overnight and it didn't log out, it didn't time out or anything. And I was able to continue working where I left off. So you may be able to do that as well if you're not doing this all in one day. But if you do close the R session, you'll have to reload all of the information that we've covered in the first two chapters of this prevalence estimate segment. All right, finally, we're going to visualize our data using bar charts. And the function that we'll be working with is called ggplot. It's a really popular and commonly used data visualization tool in R. So we call ggplot. The first command is our data table. So we're going to call in PE table 2, which is this data table that we just made. Next, we have to specify the aesthetics, that's AES, our x-axis. So on the x-axis, we want the health variable. On the y-axis, we want the proportion. And we want R to give us 2 bars for each health variable specifying the respondent's sex. So fill equals SEXX. And so if we run this line of code, it will give us just an empty graph, just a grid. In ggplot, you also have to specify the type of display. So we want to use a bar chart. So we do plus geom bar, and then this is just some specifications for that display. Stat equals identity, and position equals position dodge, which just puts some space between the bars. Let me make sure that code is right. It looks pretty good. So this is our data. These are our results. Wow, look at that. That's amazing, isn't it? So, but we also calculated the confidence intervals. So let's go ahead and add that to this figure. So let's call that command back in, and we can, for the arrow bars, we do plus geom error bar. Our aesthetic, our ymin equals proportion low. Remember, because in the PE table we had proportion low, proportion up. The proportion low is the lower limit of the confidence interval. So we want our y minimum on the error bars to be the proportion low, and the y max to be proportion up. And then we want, if we just run this code as is, it will display the error bars, but they're going to be kind of weird and out of, not exactly centered, maybe a little running into each other. So we're just going to specify some display options. Width equals 0.2, position equals position dodge 0.9. So let's run through that again. Let me put in some spaces here. All right. Oh, and I spelled geom wrong. Geom. Spelled it wrong again. Geom. Okay. Ymin. All right. I think that's. So ggplot, our data equals PE table 2. The aesthetic, our x-axis is a health variable. The y-axis is the proportion. We want to fill the bars depending on the respondent's sex. We're specifying geom bars. These are some display options. Stat equals identity, position equals position dodge. On our error bars, we want our aesthetic for the minimum on the confidence interval to be proportion low, and on the maximum to be proportion up. We want the width on those error bars to be 0.2 and the position dodge to be 0.9. And this is what we get. This is great. This is publishable. We really could write a paper together, guys. The only other thing on this table that's kind of weird, we could also specify the axes and put a title and all of this, but that's just, I think the biggest thing that we have to think about is this bottom, the way that the health variables are displayed on the bottom. They all overlap. And also looking at the columns vertically like this, it's kind of hard to really get a feeling for, the differences between genders. So let's minimize this again. And let's do one final thing. We'll call this commands back in, the previous commands, and add, so plus chord underscore flip. And what that's going to do is now we have our bar chart like this. That's just going to flip the coordinates so that the variables are listed this way and the proportions are on the bottom. I don't know if we can call this x and y anymore since we specified this is x and this is y, but it just flips the coordinates on it. So now I'm going to press enter and open that window back up, and this is what we have. All right. So let's review. Let's see who's doing better health-wise, California girls or California boys. So this, and it sorts these health variables alphabetically. So the first one is vegetables. So not eating less than one vegetable per day. More men ate less than one vegetable per day than women. So women are doing better here. This is no physical activity in the last 30 days. So it looks like there are more women not doing physical activities in the last 30 days, but the confidence bars overlap, so we can't say it's statistically significantly different. So there's really no difference here. RF smoke 3, so current smokers. There are more men who are current smokers than women who are current smokers. So there's another one for girls. RF BMI is obesity. So there are more men who are obese than women. And actually this looks like 10% difference maybe? I don't know, that looks like a huge difference. I think there might be some reporting bias here because, people don't always report their weight correctly, and I would guess women are more guilty of underreporting their weight than men, especially maybe California women. So it looks like California men have a higher obesity rate, but I'm guessing this obesity rate for women is not quite accurate because of underreporting. But based on the survey results, there's another one for California girls. Nice. This RF health was adults reporting good or better health. So both men and women reported equally as good health. RF binge is binge drinking. So more men are binge drinking than women. This is Phys 14D is somebody having more than 14 days of physically poor health. So it looks like men and women have about as equally many physically poor health days. Men's 14D is the number of people having more than 14 poor mental health days. So it looks like both men and women experience about the same amount of poor mental health days. This HCVU 651 are people with health insurance, I think. Let's double check how the surveillance system defined that. So people having health care coverage. So in our bar chart, so it looks like both men and women have about equally as much health insurance. So the proportion of men and women having health insurance is not statistically significantly different. This variable, fruits LT1A, so there are more men not consuming at least one serving of fruit per day than women. So men are eating less fruit than women. There's another one for California girls. Told high, I think this is high blood cholesterol. Let's check that. Told high, so ever told you have high blood cholesterol. So there are, it looks like men have the proportion of men who have been told that they have high blood cholesterol is slightly higher than for women, but the confidence intervals overlap, so it's not statistically significantly different. For have you ever been told you have arthritis? More women have been told they have arthritis than men. So California boys are doing better than California girls for arthritis. Diabetes is about equal. Stroke is about equal as well. What is this? CVD-CRHD4. Let's check on what that is. That's have had coronary heart disease. So it looks like men have been told more often that they have had coronary heart disease than women. So women are doing better there as well. This is blood cholesterol. No, cold check, I think is, have you ever had your blood cholesterol checked? So both men and women have, yes, equally as often had their blood cholesterol checked. Checkup 1 was, have you had a checkup in the last year, I think? Let's check that. Have you had a routine checkup in the last 12 months? And it looks like more women than men have had a routine checkup in the last 12 months. So California boys, go to your doctor. That's really important. And more California men than California women have been told that they have high blood pressure. But more women than men have been told that they have depressive disorder. And let me just minimize this a little bit because I'm thinking with my video down here, you might not be able to see this as well. All right, that should display better. Now that we've already gone through all of them, I'm moving it. Anyway, so there you have it. So overall, it looks like women have better health indicators than men based on these prevalence estimates. But what's interesting is that both men and women report a high level of good health. So this is more than 75%. That might be about 80%. So 80% of Californians report good or better health, which is that's really good. And almost everybody, I can't say almost everybody, but even more people than have reported good or better health have had their blood cholesterol checked, which is also really important. Yeah, so anyway, these are our results. This is our data visualization displayed from our PE Table 2. I am going to make a scorecard and keep track of California girls versus California boys. It looks like so far California girls are beating California boys, so you better shape up. And so what we're going to end up doing next is doing the same thing we did for this article from the CDC, the surveillance summary from the 2015 BRFSS data. We're going to select a different article and kind of mimic the analysis in the same way, look at the same health variables. So start by cleaning our data, then analyzing the data, and then, if appropriate, also visualizing the data. And then throughout this entire tutorial series, I'm going to be keeping track of whose health was better in 2017, California girls or California boys. And in the end, we'll see if our hypothesis was true or if health is about equal. So that's everything from this segment of the prevalence estimate tutorials. Yeah, if you made it through these 3 chapters 5, 6, and 7, then you're ready to write a paper. Like, you should definitely publish on this. But also, total disclaimer, I'm not a statistician, I'm not an epidemiologist. If you're actually going to be pursuing publication or presenting these findings in front of an academic or peer-reviewed audience or something like that, professionals, you should get collaborators. All right, this tutorial is more of a how-to, I'm not really a collaborator. So you should be working with a group of experts to define your health problem, the health variables of interest, populations of interest, your statistical models, statistical methods. I'm just here to help you with support in R. So on that note, thank you so much for working on this set of analysis with me. It was fun. It was tiring. And I'll see you back here next time. We'll be doing some other stuff. So now I am going to close out everything, close out my R session. We're finally done with prevalence estimates. I should save this. Close out our table. Those are just my videos. All right, so on that note, I'll see you next time. Bye.